Hello everybody, welcome back. This is the last section of the chapter on radicals, expressions, and equations. This is 5.3. We looked at a lot of radical expressions in the first two sections, 5.1, 5.2, when we added, subtracted, multiplied, and divided radicals. Now, with 5.3, what we're going to do is we're going to look at radical equations. So, first thing we need to do is we have to look at what's called a restriction on the values of a variable in a radical equation. So sometimes you'll get an answer that you think works out well when you do it, but in fact that it is no good. So that's why we have to put a restriction on our equations moving forward. So first example 1 says state the restrictions on the values for the variable in each radical equation. So in example 1a, you can see that we have the equation y is equal to the square root of x minus 5. So in order for this to be true, all the x values have to be greater than 5. For example, let's say if we used x equal to 4. If we used x equal to 4, if you put, like we solved it, we got a value of x equal to 4. Well, what's 4 subtract 5? 4 subtract 5 is negative 1, and we know that we can't take the square root of negative 1. So these are going to be called extraneous roots. Roots that you can actually solve for sometimes, but they don't actually work based on the restriction from this variable. Okay, so we'll have to use our restrictions, state your restrictions at the beginning, even if it says not to, or if it doesn't say to, I should say. So you still have to put the restrictions on there. It's very important. Okay, so basically underneath the radical sign has to be greater than or equal to 0. Very simple. So x plus 3, that has to be greater than or equal to 0. I solve for x. X has to be greater than or equal to negative 3. If not, it will not work. So for example, if we had an x value of negative 4, which we know is clearly less than negative 3, it wouldn't work, because negative 4 plus 3 is negative 1. Okay, so all you do is you take what's underneath the square root sign and you put a restriction on it by setting that greater than or equal to 0 and solving for the x. Okay, so in C, x has to be greater than or equal to 5/2. All right. Remember D, if you will. Underneath the square root is negative 3x, greater than or equal to 0. But you'll notice the inequality sign has changed. And the reason it has changed direction is because we divided by a negative value. We divided both sides by negative 3. Okay, so that's extremely important. So that means that x has to be less than 0, which makes sense, because any of x value less than 0 is a negative number, and a negative times a negative is a positive, which allows you to take the square root. Okay, and E is done the same way. We get 4 minus x greater than or equal to 0. Take the 4 over to both sides, so we get negative x is greater than or equal to negative 4. Divide by negative 1, and we get x. Now remember, it was greater than or equal to. Now it's going to switch to less than or equal to. Negative divided by a negative is a positive, so all of our x values have to be less than or equal to 4, which makes sense. Put in 3, it works. Put in 5, it doesn't work. Okay, very straightforward on restrictions. So remember, your restrictions, anything underneath the square root sign has to be greater than or equal to 0. If you have more than one square root, we're going to look at that. We have to state both restrictions. Okay? So, solving radical equations algebraically, you have to identify any restrictions on the variable, and you have to identify any extraneous roots. All right, let's look at the first equation. So there's a few little tricks what you need to do here. These ones are set up pretty easy, but when we get into some of the other questions, I will help you with that. So the first step here is basically you want to get the radical to one side and anything else to the opposite side, which in this case it already is done for you. You'll see that later on in the next example. So I square both sides. By squaring both sides, I get 3 squared is equal to the square root of x minus 3 all squared. So if you take this, if you square the square root of something, it just gives you the radicand, right? What's underneath the square root sign, which is nice. So square root of 3, I get 9. I square root, I get 2x minus 3. Add 3 to both sides, I get 12 equal to 2x, and x is equal to 6. Remember your restriction? I did that up here. That actually should be written as 3/2, not 5/2. So that's a typo. I will fix that now. All right, my apologies. Got that all fixed up. We have the 3/2 here, obviously. 2x minus 3 greater than or equal to 0. Take the 3 over, divide by 2. All your x values have to be greater than or equal to 1.5. Right? So if you put a 2 in here, that works because you get 1. If you put a 2 or 1 in here, it wouldn't work. You'd have -1. Right? So just be careful there. So x equal to 6, it satisfies it, so we can continue. You want to do a quick check. Plug it back in. 3 is equal to 3. There we go. We're good to go. And that checks for extraneous roots, because sometimes this will not check out. So you have to verify all of these. Okay. So it has to pass the test of the obviously passing the restriction and spilling back into the original equation. Those are both ways that we have to identify any restrictions and identify any extraneous roots, right? So both have to check out. All right, so same thing. We have this, the square root of -3x, which we learned before. Obviously, all the x values has to be less than 0, right? Any negative value would make this work. Any positive wouldn't. Okay, so we square both sides. We get 36 is equal to -3x, and we divide both sides by -3, and we get x equal to -12. Plug it back in, and it works. So it checks out on the restriction, and it checks out when we plug back into the original. So it is a good solution. All right. So the answer is x equals 6 here, and the answer is x equal to -12, and you verify them both. All right. Let's look at C. Remember, you don't just square it right away like we did in the previous examples. We have this +2 over here, so what we want to do is we want to take the +2 and subtract it from both sides and then square it. If you want to square this, it gets a lot more complicated. So you want to be able to make your life easy as possible, and that's how you do so in this particular example. Okay? Remember to state the restriction. The restriction is x has to be greater than or equal to 2/3. Okay? So it's important. So we subtract 2 from both sides. Then you're going to square both sides. -2 squared is 4. The square root of anything squared is itself, so it just becomes 3x minus 2. We add the 2 to both sides. We get 6 equal to 3x, and divide both sides by 3, and we get 2. This is an extraneous root, not because of the restriction. It passed the restriction test, but it did not check out when you solved, right? So when you plug it back in to remember the original equation, which we've done, so 3 times 2 is 6, 6 subtract 2 is 4, square root of 4 is 2, and 2 plus 2 is not equal to 4. And obviously some of you are saying, yeah, that's because this was square root of 4, could be -2, and the -2 would work. You're absolutely right, but when we check these equations, that's not the case. We don't worry about the negative, we're only worried about the positive value for solving these equations. Please recall that, okay? Or remember that, I should say. Next one we have here looks complicated, but it's not. We subtract the 3 from both sides. We get -7 subtract 3 would be -10. We square both sides. Negative squared is positive. Square root of x squared is obviously x. X is equal to 100. It passes our restrictions of where the x has to be greater than 0. Let's check it out. Put in 100. The square root of 100 is 10. 3 subtract 10 is -7. -10 is equal to -7. Therefore, x is a solution. So this x equal to 2 is not a solution. So there's no solutions here. Okay? Here there was a solution. Here there's not. Alright? Let's look at E. So I put the restriction. The restriction is x has to be less than or equal to -5/3. I didn't include this restriction x because x could be anything here because you're squaring it, right? So if you square a negative, you're going to get positive and whatever, right? So there's no restriction on this radical, but there is on this side. So if you have a radical equal to a radical and there's nothing else, then you just square them immediately, okay? And you'll see how easy this simplifies down. So you get 2x squared equals -15x minus 25. Take everything to one side, set it equal to 0. You're noticing, yes, you're ending up with a quadratic, but that's not a big deal. So once you have the quadratic, 2x squared plus 15x plus 25, what you want to do is you want to use decomposition if possible, which I noticed that two numbers multiplied together to give me 50, added together to give me 15 are 10 and 5. So I split the 15x into 10x plus 5x. I factor a 2x out of the first two terms. I factor a 5 out of the second two terms. Both leave me in x plus 5 decomposition. So I end up with 2x plus 5 and x plus 5 equal to 0. So that means that x is equal to negative 5 halves and x is equal to negative 5. They both satisfy the restriction, so we can continue on with them. You need to check them both. So that's what I've done at the bottom here. I've checked negative 2/5, and I get the square root of 25 over 2 equal to the square root of 25 over 2. And then I check the negative 5, and I get the square root of 50 equals the square root of 50. So both are okay on the restrictions, and both are okay when we satisfy them by checking them for any extraneous roots. Let's look at example F. Example F, we have the square root of 4x squared plus 5 is equal to x plus 2. There's no restriction on the x value because this is x squared. The square root of x squared, again, if this number is negative or positive, you're going to square it, so it's going to become positive anyway. So any values will work, so there's no restriction on the x value. We're going to square both sides. There's nothing we can do with this, right? What we do is we want to have one radical on one side and then the rest on the other side, essentially. If there's two radicals, then we're going to have two radicals. We'll get to one that's a little more complicated that it won't work. You just have to do what you can with that. But remember, if you can get one radical out by itself and the rest on the other side, that's your goal. Okay? So I square both sides, so I get 4x squared plus 5, and then I square x plus 2, which is obviously going to be x squared plus 4x plus 4. I set it equal to 0, so the x squared comes over and it gives me 4x squared minus x squared, which would be 3x squared. Minus 4x comes over and I get minus 4x. And then I subtract 4 from both sides, so I get 1. So I have this nice quadratic equation. It's equal to 0. Now I'm going to use decomposition. So the 4x becomes 3x and minus 3x minus x. Group these together, factor out to 3x, so I'm left with x minus 1. Group these together, factor out a negative 1, I'm left with x minus 1. So one factor is the two GCFs that I pulled out from decomposition, 3x minus 1. A common factor in both, obviously, that's what decomposition does for us. You get x minus 1. So there, that tells me x is equal to 1/3 and x is equal to 1. So we're going to verify both of these. I'm going to verify the 1/3 first, and when I do, I get 7/3 is equal to 7/3, so that's okay. And I'll verify the 1, and that works as well. So no extraneous roots. Both roots are good to go. All right. So on the next video, what I'll do is I'll finish GH with you. These ones are a little more complicated, and then we'll go from there. So we'll see you in the next video for the last video on the last two questions for radicals, radical equations. Thank you.